Okay, we've got our first position, velocity, acceleration problem. Now, these problems are interesting because position is sort of your parent function, velocity is your derivative of position, and acceleration is the derivative of velocity. You really don't know if it's going to be an antiderivative problem or a derivative problem, because if they give you, for example, position and ask you to find velocity, well, then you're going to take a derivative. But if they give you acceleration and ask for velocity, it might be an antiderivative. So in this case, let's make sure we're reading this problem really carefully. A particle moves along the x-axis at any time t equals 0. That's pretty standard. Its velocity is given by blah, blah, blah. So we are given velocity. Let's see. Now this is interesting. They give us velocity, so they could be asking about acceleration, in which case we take a derivative, or they could be asking about position, and we'd have to set up an antiderivative. If the particle is at position x equals 7 at time t equals 1, what is the position of the particle at time t equals 2? Okay. Now this is, they're asking for position, so it's an antiderivative problem. Not only that, it's a specific problem. So this is almost like initial condition. So we have to take the antiderivative of 4 minus 6t squared dt. Make that 4 a little clearer. And where should we start? Well, we're going to start at t equals 1. Why t equals 1? Because we know that the value there is 7. So if we go from 1 to 1, 1 to 1 is 0, and we'd have 7. That's sort of how we set these intervals up, these antiderivatives up. So we're going to go ahead and plug in our x there. Excuse me, it should be t. Take our antiderivative here. And our antiderivative is going to be 4x minus, keep doing this, 4t, minus 2t cubed plus c. Now the plus c matters, okay? The plus c matters. Why does the plus c matter? Well, it matters to solve for it because we're going to need to understand what the value is at t equals 2. So we're going to have plus c equals 7 at t equals 1. So we're still using t equals 1. We're not using t equals 2 yet. Plugging in t equals 1, we get 4 minus 2 plus c equals 7. 2 plus c equals 7. C is going to equal 5. Now I can go ahead, make this 5 back here. Now I can plug in 2 into these values. Doing that, I get 8 minus 16 plus 5. This is no longer equal to 7. And this is going to be my value. So let's go ahead and see if that is -3. Pretty challenging problem here. Pretty cool if you can figure it out. Alright, I'll see you guys back for problem 10.